So what we're looking at today is kind of like the reverse of what we were doing yesterday. So you want to graph the points, you want to plot the points in the table, and then decide what function does it represent. So if we go ahead and graph -4, +4, we go left 4 and up 4, put a dot, -2, +2, put a dot, 0, 0, and +2, +2, +4, +4. So there's our function. So you go to your notes and just ask yourself, what function does that look like? And it looks just like the absolute value function. This goes up 2 and over 2 and up 2 and over 2, but the absolute value function goes up 1 and over 1, but it'll end up getting to the same place. Right? So up 1 over 1 is the same slope as up 2 and over 2. So yeah, this is the absolute value function. Okay, so what function does it represent? It represents the absolute value function. And then I want you to give me the equation as well. Okay, so what's the equation? Well, this looks just like the parent function. So it's simply the absolute value of x. So y equals the absolute value of x, or f of x equals the same thing as y. So yeah, that's what you want to do. You want to graph the points, plot the points, and then decide what does the equation look like based off of what the graph looks like. So you're taking the graph and finding the equation. Okay, so at this next one, at -2, +4, and then -1, +1, 0, 0, +1, 1, +2, 4. So there's the dots. And this one is not absolute value because the increase does not stay consistent. Right, so this one is the quadratic, because the quadratic goes up 1 over 1 and then up 3 over 1. So that's what we're looking at here. So the quadratic function. So this is a quadratic. And what's the equation? Well, it's exactly like the parent function, right? Nothing changed. The vertex is at 0, 0. So the parent function is the same as this one. Okay, so that's all we're up to. Okay, let's check out this next one. This -1 error just says -1 is not in the domain. It doesn't work in this function. Okay, so let's graph the rest of them. 0, 0, 1, 1, 4, 2. Something happened there. 4, 2, and 9, 3. There we go. So what does this one look like? Check your notes. Figure out what function that looks like. And this one looks like the quadratic. Or sorry, the square root. It's the inverse of the quadratic. So this is the square root function. And it looks exactly like the parent function. The endpoint is at 0, 0 there. So nothing's changing. The up and over is the same. Up 1 and over 1, up 1 over 3. So this everything matches the parent function. So we know that this is simply f of x equals the square root of x. Okay, this next one, let's go ahead and graph it. It says -2, +6, -1, +5, 0, +4, 1, +5, and 2, +6. Okay, now that does not look like any of the parent functions, but it does look like an absolute value function. It's going up 1 and right 1, up 1, right 1, up 1, left 1, up 1, left 1. So that's an absolute value function. Okay, by the way, it told us that right there. So we know it's an absolute value, but it's not the parent function. So what changed? The parent function is this one. So here's the parent function. You don't need to graph it, but you need to know what the parent function looks like. And what changed? What changed from the parent to the one we're looking at? So we went up 1, 2, 3, 4, right? So the vertex moved up 4. So what rule does that for us? So we know that if the function gets added by some number, k, that should be in your notes. it's not, go back and look at those other videos and write some notes on them. So f of x plus k is going to move something up. It's going to translate it up. It's going to shift it up. So all we have to do is figure out how far up did it go. So it went up 4 units. So we'll take the absolute value, f of x equals the absolute value of x, but then we will shift it up 4. So we'll just add 4 to it. So yeah, you're taking the graph and finding the equation instead of taking the equation and finding the graph. All right, so this next one says we have -7, +9, -6, +4, and -4, -0, -2, 4, and -1, 9. Okay, so what's this one looking like? It almost sort of looks like an absolute value, but if you look at it close enough, you'll notice it's not, because to get from the vertex point to the next point goes up 1, 2, 3, 4, and to get from the next point to the last point, go 1, 2, 3, 4, 5. Okay, so the increase is different. So this is actually a quadratic graph. It's just not giving us 2 of the points. Okay, it didn't give us these 2 points. And now it looks just like your quadratic parent function, except it's shifted. Okay, so which direction is it shifted? So the normal parent function, vertex starts at 0. This one's just shifted 4 units to the left. Okay, so it's a quadratic that takes the parent function x squared and shifts it 4 to the left. Well, how do I do that? I know that if I add some number inside the function, it's going to shift it to the left. So I need to put some parentheses, and I need to add 4. Add 4 on the inside, and there we go. This function here will give me the graph. Okay, let's look at this one. Another error. Okay, so we don't have to graph that, but just don't completely neglect it. So let's graph the rest of them. -4, +2, -3, +3, 0, 4, 5, 5. Okay, what's this one look like? Now, because of that error, I know that nothing over here exists in the graph, so this one is going to be a square root function. Okay, and again, it told us that, but even if it hadn't, we could figure that out based on the points. Okay, so how does this compare to the parent function? Look in your notes, look at your parent function. It should look like this. Your parent function looks like that. So this endpoint is shifting. It's shifting to the left, 1, 2, 3, 4, and it's shifting up 1, 2. Okay, so how do we shift things left? Remember, we need to add on the inside to shift it left. So that's going to make it go left 4. We need to add on the outside to make it go up 2. Okay, so take your function. It's a square root of x. So in the inside with the x, we're going to take x plus 4. On the outside of the square root, we're going to put a plus 2 to move it up. Okay, so that's the idea. You want to make the graph, and then find the equation that would fit that graph. If you have questions, make sure you ask.